Okay, let's get going. We're going to get into some of the key things that we need to do inside Python, variable types and arrays. And this may be useful for some of the upcoming assignments. Okay, so if you have a chance, go ahead and click on the course calendar, and we're going to look at Notebook 3. So go ahead and get that open. And I want to make the point that the your area of the UNG Data Hub, it actually saves a copy of the file with whatever you type into it. So you can put notes in there. Okay, so let's talk about that. Let's get the notebook open. And also remember, we talked about this. There's an initial code block that where normally the student will just leave it alone, but we are importing the data science package. We are creating an alias for NumPy. And again, you'll see those statements in there. Again, make sure that that's initialized, or some of the things that we need for scientific computing will not work. And before we jump into the table methods, let's go in. All right, and sorry, go to the course calendar. All right, and I want to remind you there's a link to the book and there's a link to Python reference. And when we are looking at things like sort and descending equals true, if you forget about those, they're in the Python reference. Okay, and especially the dot where with the predicates, all the predicates are listed in the Python reference. Okay, so be sure that you know how to get those, and let's go into Notebook 3. I'm going to pause the video for a second while it loads. Okay, so that took a second, but here we are, we're back. So please go ahead and pause the video if you need to and open Notebook 3. That's where we're working. So let's go ahead and get started. The Notebook 3 starts with a quick review of methods that we talked about. So dot select, what does this do? Remember, the table has a list of columns, right? And at the top is the name of the column or the variable. And so dot select will select a column from a table. All right. And we'll just display that. We can select more than one. By naming more than one, we can say select two columns. Dot sort, and remember descending equals true. We can reverse the sort with descending equals true, but dot sort, we just name a column and it will sort the whole table based on that column that we specify. Dot where, this selects rows. So a lot of these table methods deal with the columns, but dot where selects rows where we have all kinds of options. Um, like we did skyscrapers that were above 300 meters tall. So we used a dot where with an R dot above. Okay. And then remember dot show has some parentheses after it, and we say how many rows of the table we want to show. And this is a big time saver. All right, and remember, show with empty parentheses is show all, but be very careful with that as the table may be long and you may not want to show the whole thing. And this is a quick list of a couple important predicates, r dot between, r dot above, r dot below. And again, I pointed that out that the course calendar has a Python reference guide. So in D2L, when you look at the course calendar right at the top, check that stuff out and make sure that you can access it when you'd like to. Okay, so, and I'm sorry, let me jump back in. We will talk about the three basic data types, but we were going to discuss the tables, and we're using the skyscrapers table, and we're immediately doing a show 5. Once again, we're seeing that the table is loaded. We can see what columns are in it, but show 5 only, cuts off, well, it saves space. We don't have to have a huge data table. And then the skyscrapers dot select, so name and height. In this case, we're just going to get the column name and the column height. Okay, so we're just going to know the name of the building and how tall it is. And we see that the World Trade Center was 541.3 meters. Okay. Skyscrapers drop. Okay, so let me throw skyscrapers in here just so we can look. Skyscrapers. Why? Well, because I just want to take a look. Drop it has three columns that it wants to drop. Okay, so the skyscrapers dot drop is saying drop the column completed, drop the column city, and drop the column material. So we're basically just going to have name and height, which is exactly what we did right above. Fair enough, but let's see it in action. And yes, we do in fact have the name and height. So we can use select to specify a smaller number of columns, or we can use dot drop to drop some columns out. Whichever way works is helpful. And then again, displaying the skyscrapers table, and they're saying, hey, show all the Los Angeles skyscrapers. Again, the show with the empty parentheses. Afterwards, dot show empty parentheses is show all. And there just aren't that many, okay? Um, and we know how to show just the one, the name. And by the way, we do have this r dot equal to, um, and here's kind of the cool thing. It works either way. So I don't have to put in the r dot equal to. The dot where anticipates using r dot equal to. So if I just specify the column and the very thing I'm looking for, exactly what I'm looking for in that column, then the dot where works without the r dot equal to. Okay, so it's kind of a quick step there. It just assumes you mean r dot equal to if you leave it out. So we can sort based on completed. Notice that this will put the earliest buildings first, and we see the first one completed there in 1909. And like I said in the slide when we were warming up, I remember that you can reverse the sort with descending equals true. And here will be the most recent buildings first, all of the Chicago skyscrapers. Now notice we've created a new table. And the new table is only the rows of the big table, of the skyscrapers table, where the city is equal to Chicago. Okay. And now we're only going to get steel buildings in Chicago, and we're going to support the most recent one. Excuse me. We're going to show the most recent ones and sort with descending equals true. So that's just a quick review of some of those basic table methods that we learned, dot select, dot drop, dot where, dot sort. And those are important. We use them all the time. Okay. So let's look at these numbers. We have three basic types of data. We have integer data, we have real numbers, and sometimes we want to put text in. Okay. Of course, every computer package calls them something different. And for Python, integer makes sense. It's int. Text does make sense because str is the beginning of the word string, and text variables are called string variables in computer parlance. Float is kind of a weird one for us, but that's what we basically mean when we mean some real number. Okay, and how do we tell? Well, the integers will just have the number. If it's a float, it will have a decimal place. So even if it's an integer like 3, the computer will put it as 3.0 if it actually is a float variable. And if you ever don't know what it is and want to, you can use the type command and it will tell you what data type that thing is. So let's take a look at the notebook. And again, 4 plus 5, that is an integer. Okay, 20 is an integer. This one, of course, is a float, a real number. Notice this, that it puts in a decimal place. So this is Python's way of saying, hey, this is a real number. This is a float. Okay, and I understand that it doesn't need to be because 20 divided by 2 is 10, but some divisions that it does, it goes ahead and turns the answer into a real number. That's just how it stores it. It's not a big problem for us. It just stores it as 10.0. Now, this is 1, 2, 3, 4, 5, 6, 7, 8, 9 raised to the 50th power, which is an integer. But notice that if I want to force it to use a float instead of an integer, that I can specify, right? Why do I do that? I just put in a dot zero, a decimal place and a zero, and then it switches to a float. And you notice in this case, it switched to scientific notation. And you see it right here at the end, the e plus 161. That means times 10 to the 161st power. Okay, and you want to contrast that with the one right below it, which is an integer. Okay, so we can force Python to store it however we'd like, integer or real, as long as it is possible to be stored as an integer. Okay, 4 divided by 700 is obviously a float. 4 divided by 7,000. So these, when it switches to scientific notation, we know that that must be a float type variable. Okay, this is a real number. We put it in its decimal form, so it's showing that. Now notice this is very similar. So the first number is only different in the last few spaces. So what we're doing is we're doing a subtraction of two things that are close to each other, and an interesting thing happens. Even though the answer should be this that I'm highlighting, I'll get right. It should be this when I subtract the two numbers. Oh wait, I'm not going to the right place in the numbers, sorry. Trying to find 1, 2, 3, 4, 5, 7, 8, 9, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, right? So 1, 2, 3, 4, 5, 7, 8, 9, 0, 1, 2, 3, 4, 5, 7, 8, 9. So it's actually this part of the number that's different and it should show up, but we get a 0. All right, so this is a problem with floating point arithmetic, which is what these floats are named about. And there's a problem in the computer that when two numbers are very, very close to each other, subtracting them causes some problems. Okay, and so what's happening here is it's just giving you 0 because it can't really successfully figure out that number, how it is small, it's close to 0, but the computer is struggling with it. Okay, so remember when you subtract two numbers that are very close to each other with the computer, it may cause a problem. Now, 10 raised to the 1/2 power, that's the square root of 10, which is just a little more than 3. The square root of 16, notice that it gives us 4.0, which means when we're doing this square root, it's just assuming there's going to be a real number. So it stores it as a real number, even though it would be an integer. 30 divided by 10 also gets stored as a real number. Now look at this, integer of, oh, so it'll take a real number, and when I say, hey, I want to see the integer, so we have actually three functions. We have int, we have float, and we have an str. So we can change the data type. This is a real number, and we can say, hey, I want the integer of this real number. And here it doesn't round. Be careful with that because it just takes the integer part. It just stops after the decimal place and only takes what's before the decimal place. Notice that we can round a number, and that will round up to 3. And we can take an integer and convert it to a float by saying float 3. 6 divided by 4 is 1.5. And this is, well, you should see a big difference, okay? But now notice that we have this that's in the denominator times this thing in the numerator, and they should cancel each other out. We should just end up with 6. Aha, okay, so it does work. And then 6 divided by this number, right, is equal to this denominator, which sorry, should be equal to, yes, that, and which is equal to 4 times 10 to the 56th power. All right, so Here are a couple of variables, and this is just review. And integer y. So notice this integer, when I put something in quotes, the computer thinks it's a string. Even if I put a number in quotes, it will treat it as text, not the actual number. Okay. So same with integer z though, notice that it's a real number. All right. So I can convert it to a float, right? Wait, sorry. I see that. All right. I can convert it to a float. I can take the 5.6 and convert it to a float. And if it's converted to a float, I can then convert it to an integer. But if the thing that's in z, 5.6, isn't an integer already, right? I've got some issues. It will work okay with real numbers, but it won't work with a string. Okay. And again, round 5.6 is going to go up, so be careful with the int function. It doesn't give me the exact number. It gives me everything before the decimal place. And notice that this says round 3, so you'd think there'd be 3 decimal places, but when they aren't there, it just gives me a placeholder. And here the 10 times 3, even though 3 is an integer, I put a 3.0, so it stores it as a real number and then does the multiplication and puts the answer as a real number. Okay, so strings. So again, strings are essentially text. And like we said above, a string can contain or consist of a number. Okay, so 99 bottles of root beer. Single quotes or double quotes will work. Baby Yoda isn't Yoda. Notice that she said hello. This is why we're allowed to use double quotes and single quotes, because sometimes we have quotes inside quotes that we need to deal with. And so that's possible. And then with Baby Yoda isn't Yoda, there is a single quote inside there. Notice that we can add straw and berry to get strawberry, but we cannot add 3 plus berry. Okay. We can add straw and berry with a space in between. That's not really how it's spelled, but we can do that. That's possible. Look at the 10 times ha. Okay, so some of these arithmetic expressions will work with strings. LOLOL. But we don't often use this. This is just a kind of a FYI, sort of like for your information. We don't do a lot of this. There's 1 or 2 items in the labs and homeworks that do things like this. Main thing that we need to know about strings is to make sure that we put them in quotes, okay? And the type function we said will let us know, by the way, this is going to be an array. We will talk about how to use the make underscore array function. And it does just what it says. It makes an array, and you can see that. And height item 2. So it created a variable that is an array. It's this list of numbers. And so the second one you'd think would be the second one, but no. Let's take a look. The computer starts counting at 0. So this is item 0, 16 meters, and item 1 is 17 meters, and item 2 is 18 meters. So it is the second item, but the way the computer counts, starting at 0. The computer always starts counting at 0. And notice that the type is a string. Okay. Um, these are, we entered them as quotes. And by the way, 18M, that there's not a way to enter that without quotes. So type of height type is an ND array. Okay. A equals 10, type says integer, type of 4.5, that'll be a float. Type of ABC, that's inside single quotes, so that is a string variable, str. Type skyscrapers, that's a table. Okay, so it's saying, hey, that's a table. It uses this package, data science, to handle those. Type true, like when we say descending equals true when we're sorting, that's bool for boolean. Okay, that's on or off, yes or no, true or false is a boolean variable. The type of abs is a built-in function or method, and you can see that they will let you know what these things are. Also, when I round 3.4, it rounds to an integer. And this one, even though we rounded it, it's still a float. Again, floating point arithmetic is a thing. It's how we can help the computer be more precise so that we don't lose the digits like we did in that subtraction up above. Type 3 is a string and type 3 is an int. All right, so those are the different types. And again, please remember that you can use the type function to figure out what something is if you need to know. Okay, so we showed make array before, so we're going to make array that's titled my array. And sorry, give it just a second here. Oh, and it's not showing it. I'm sorry, because it's not the last thing. Okay. I can make it show if I do a my underscore array. Sorry. Um, by the way, if you want to delete an open cell that you don't need, dot dot, delete, excuse me, DD is what you can do. Now be careful with that. It's lowercase d's, and you don't want to accidentally delete half your homework. But if you do need to delete a couple rows, click on the number, right? And DD will get rid of it. Okay. So my dot array, what happens when I multiply my array times 2? It takes every single number and multiplies each one by 2. Okay. And my dot array raised to the second power. Notice that it's still the original array, 1, 2, 3, 4. 1 squared is 1, 4 squared is 2, 3 squared is 9, and so on. My dot array plus 1 will work just like that, adding 1 to each thing. And notice that my dot array is unchanged. So I'm just going to go plus sign so I get an extra one here. And if I type in my underscore array, I said my dot array, but my underscore array is still just equal to 1, 2, 3, 4, even though I've been doing various things to it. Okay, now here we're creating another array using make array, 60, 70, 80, 90. And my array plus another is 1, 2, 3, 4 added to 60, 70, 80, 90. So it adds each component. So it adds the two first components together, right? So it adds the 1 and the 60 and gives me the 61. It adds the 2 and the 70 and gives me a 72, and so on. And let me get rid of the ink. Okay. Okay, yet another and make another, yet another is equal to make array, 5, 6, 7. And notice that my array is 4 elements and yet another is only 3 elements. And as always, when we have an error message, always read the last line first. And here it even says, oh, shapes 4 and 3. So one of the arrays had 4 items in the list and the other one had 3. And it said, hey, I can't do that. All right, and it also has a little line, a little arrow that points at exactly where the error occurs. So again, always read those error messages starting at the bottom, the last line first. Okay, and what was I showing here? So what you can do, if you would like to, is you can open up an extra cell and you can type notes. So the cool thing about, and this is, it thinks it's code right now, so I'm going to switch it to Markdown. Okay. Um, so, so the cool thing is, remember in the data hub, every single one of these files is saved and it's your personal copy. So you have your personal area in the UNG data hub. And now this file, this notebook 3 file, is your file. And if you hit save, right, it will save the things that you want to type in. Now, there are lots of ways to take notes in the class. But one good way for this online class is you can just pause the video and you can type in any notes that you'd like to be able to remember. And then you can just come back to the notebook and all of your notes will be saved. Okay, if you want to take notes in a notebook, longhand while you're working, that's fine. But I did want to make you aware of this possibility for note taking. My array is still 1, 2, 3, 4. The length, so LEN is short for length, and there's 4 items in it. And the sum of those 4 items is 10, and the sum divided by the length is 2.5. That's the average. And oh, notice that we have an error code. And if you read the bottom line in the error code, it says not defined. Name average is not defined. You're like, what? A computer doesn't know what average is? Well, it turns out, no, it doesn't. And we mentioned this, that's why we have NumPy. It's a special package that'll bring in these things that Python doesn't know about natively, okay? So, and it will do the average of my array. Another is an array that's 60, 70, 80, 90. The length of yet another, if you remember that one was back up here. Yet another is 5, 6, 7. Okay, so yes, its length is 3, as we can see. I can make an array of text. Okay, so these are types of tuna, bluefin, albacore, and so on. So tunas is just an array of words, of strings, okay? So what if I try to add up tunas? And it says no, 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 right? Unsupported operand types for integer and string. It's like, look, I can add up integers if you ask me to, but I don't know what to do with strings. I don't know how to add strings, okay? So so I can make an array of numbers. I can add those up if I'd like to. Now, we said earlier that the columns of tables are arrays. Okay, so here we're using the skyscraper data set and the dot where to get just the San Francisco skyscrapers, okay? And when I do sf.select and I specify height, I just get the height column. And notice it's just the 4 numbers in the height column as an array. So I can take, this is cool. So dot column works just like dot select, except look at the difference in the output. Dot select keeps it in table form. Dot column says, hey, give me those same numbers, but give it to me in an array. All right, and what's cool is that I can take the dot column height and I can change those meters to feet by multiplying by 3.28. And then I can add that column to the table and we're going to call it San Francisco new. Now, this is a preview of coming attractions with underscore column because it will allow us to add a column back in. And we'll go over that in a lot more detail later, okay? But just know that it's possible for now. And the San Fran table is still unchanged. San Fran column 0. What? Column 0? That doesn't seem to make any sense. So what is it listing? If you notice, it's actually listing Transamerica Pyramid and Millennial Tower. So the computer starts counting at 0. So the first column, what we would think of as the first column, is 0, and this what we think of as the second column is 1, and then 2, and then 3. So just remember that the computer starts counting at 0, okay? So MP average, this is the average height of the San Francisco skyscrapers. Here are the Los Angeles skyscrapers. Remember, .show with open parentheses is show all, okay? And here we're finding the average height of the LA skyscrapers and using .column to pull out the height of the San Francisco. So what is the average height of the LA skyscrapers minus the average height of the San Francisco ones? Well, about 4.6 meters. And we can also find out that the average height of the LA skyscrapers is about 231 meters. Okay, well now we're going to look at all the New York skyscrapers. And look, it omitted 63 rows. So there's 73 skyscrapers in there. And it's saying, hey, let's use dot column to pull out the height column as an array and take its average. And then we can take the average height of the New York skyscrapers and subtract the average height of the LA skyscrapers. Now we have a table named not NY, which is all of those that are not equal to New York City. Okay, so it's going to get everything, every city except New York City. And then also RDOT contained in Los Angeles and New York City. We did this last time, but it gets all the New York City and Los Angeles skyscrapers. But look at this, R dot not underscore contained underscore and are not contained in. So when I do this, it'll get everything except the Los Angeles and New York City skyscrapers. Okay. Length of New York column 3, that's 73. We said there were 73 skyscrapers in the New York with the New York City. Notice this though, we're learning a new method. The new method is ny.numRows, and notice that it just tells me how long the column is or how many rows are in the table. And this is really useful. Again, we'll go over this in more detail, but please remember this num underscore rows is a great method that tells me how long the table is, how many rows are in the table. By the way, we can also tell how many columns are in a table, and we'll go over that in more detail later. So the final thing that we're going to do is we're going to look at some graphs. Okay. And there are some typical visualizations that we use in statistics. So these are traditional statistics, visualizations, the scatter plot, histogram, a bar graph, and a box plot. Blocks plot. Okay, that's got an extra L in it. It's just box plot. um, so sorry about that. um, and we can also use the dot group methods. This is a little preview of coming attractions. It turns out that we can summarize category variables using the dot group method. Okay, so let's get rid of the ink and check back into the notebook. Now, what's this? This is just a dot plot, okay? um, and it shows the heights of all these skyscrapers and the years completed. And what's the dark blue bit? Okay. Um, those are the LA skyscrapers, right? So the red ones are the New York skyscrapers. How do I know that? Well, I'm looking right above it. I'm seeing, oh, New York. And then here with dark blue, I'm looking right above it. Oh, LA. Okay. So I've got LA and New York. Okay, so this is just a plain old dot plot. What do we have here? These are box plots. Okay, so a couple of things to note about a box plot. The top is the maximum, the bottom is the minimum, which you'd think. What are these two lines at the top and bottom of that rectangle? Well, they are the 25th percentile and the 75th percentile, and the median's in the middle, which is roughly the 50th percentile. So the box plot shows me all the percentiles, all the quartiles. Goes 0 and then 25 and then 50th percentile, then 75th percentile, and then maximum. Okay. Let me get rid of the ink and move down. Okay. And here is a box plot that compares New York City and LA skyscrapers. Okay. And now we do a bar H. What's it doing? Okay. So we sorted based on count descending equals true. Let's do this. I'm going to put a hashtag in here, which allows the stuff that's after the hashtag to be a comment. So now, what does it do with skyscrapers.group city? Okay. Well, it singles out every time it sees a city name and it counts how many there are. And so there are 36 Chicago ones, and so we go on. Okay. Well, let's go up and look at this. So what are we doing? After we group based on city, we're sort based on count. Well, notice that count is something in this grouping table, is a name of a column in this grouping table, and they're going to do descending equals true. What's that going to do? It's going to put the city with the most number of skyscrapers at the top. So it's going to sort from least to greatest based on what? Based on city. So it's going to sort based on count and do a bar graph. Bar H is a horizontal bar graph based on that. Okay, boom. And get rid of the ink. So we see that New York has the most, and then Chicago, and then Houston, Los Angeles, Atlanta is number 5 in the list. Interesting. Okay. So we can do a skyscrapers, and we're grouping by city where that city has at least 5 skyscrapers. Okay, so now we're also going to do a bar graph again, but we're only going to do a bar graph with the cities that have at least 5 skyscrapers. Okay. And here we're going to do r dot above. We're going to do, we're going to show how many skyscrapers that these cities have. Okay. And what else do we have? These are cool ones. So we can use these dot groupings, this dot group in a lot of ways. And here, these are skyscrapers where the count is above 7, sorting based on the count. Okay, so you can see these are the cities with 7 or more. Here's the same thing, but with descending equals true. Not quite the same thing. This is, yeah, where count is above. Yes, it is. Okay. And then we're doing what? Where the count is above 7, sorted based on city. So now we're sorting alphabetically based on city name. Okay, so that's a little bit of a preview of coming attractions. We'll learn a lot about the DOP group and how to help summarize category variables in the future. And now, are you ready to talk about ranges? Okay, so make array, we've already learned how this works. It just makes an array. But look at NPA range 6. So it makes a 6-item array. So notice that the NPA range, I'm saying it A range because it's not the word arrange. The word arrange has 2 R's in it. Okay, so NPA range, it's creating a range. And it starts, if you don't tell it a start place, it starts at 0 and it goes up by ones until 1 before. It doesn't go all the way to 6, it goes until 1 before the item. And notice that it does create a 6-element array. If you count these, there are 6 elements in there. NPA range 7 is a 7-element array, so it starts at 0 and it goes up to 6. Now, I do want to point out that this is not going to go from 3 to 9, it's going to go from 3 to 8. Why? Because the NPA range function always counts up until one item before the number that you put as your stopping criteria. So we have starting criteria in this row is 15, stopping criteria is 7, and we're counting backwards by 1. The -1 means we're counting backwards by 1. So it goes 15, 14, and notice it always stops one item before the stopping criteria. 1 to 21 and count by 2s. So the start at 1, count to up to 21 by 2s. And notice that it stops. The next item would have been 21, but it always stops one item before the stopping criteria. What's going to happen here? 0 to 21, counting by 2s, it gets to 20. Okay, so whatever item, if it's going to go past that item and get 2 or above the stopping criteria, it's going to stop. Okay, I can count by non-integer amounts. These are all the 100th numbers between 0 and 1. Okay, and just going back, NPA range 7, remember it starts counting at 0 and it counts up to 6 and stops 1 below. And the 6th item in NPA range 7 is 6. Why? Because it starts counting at 0. Okay, item 0 is in fact 0. And B, item 49 is from the hundredths. So the 49th one in there, it started at 0 and then 1 and then 2. So the 49th one is actually 0.49. All right. Again, this is a really important uh, preview of coming attractions. This NPA range, we use it all the time. So take a moment and play around with that if you'd like to, but definitely learn it because we are going to be coming back to that quite often. Okay, that's all I've got for you today. Have a great afternoon.